Hello everyone, my name is Muhammad Jeffrey and my student ID was 2024242144 and I'm from class 1433E. So today we are going to talk about our assignment, which is STA150. So let's start with the introduction first, which is the background of the experiment. So the study will conduct an experiment by tossing a coin by one partner to produce a good trials. The other member will record the result. Subsequently, 13 trials outcome will be recorded. So all the questions below need to be answered based on the output that we got. Objective of the experiment. So one of the objective is that to record the possible outcome of the experiment for getting a head and a tail. The second one is that to calculate the probability of the outcome by randomly tossing a coin for 13 times. And the third one is to calculate mean and variance by using the formula that we already learned before. So the fourth one is to find the difference between experimental probability and the theoretical probability of the outcome. Significance of the experiment. So the significance of the experiment is to enhance our understanding of probability and its applications in real life situations. The experiment focuses on the outcome of a coin toss, where we aim to determine the probability of obtaining heads or tails. From the experiment, we calculate the experimental probability obtained from actual result and the theoretical probability based on the expected outcome. Through this, we can compare the result and we will see that the difference between the experimental and theoretical probabilities of obtaining head and tail alike with the result of the experiment. Procedure of tossing a coin is we just need to choose any coin, for example 10 cents, and decide which side is head and tail, and then place the coin on our index fingers and thumb to bend it slightly if needed, and then use our thumb to apply force to the edge of the coin so that the coin will spin in the air for several times for a fair toss, and then catch the coin on our palm to look out for the outcome, for example like this, right? So look at the side facing outward. The side visible is the result as a head or tail, and record the result and repeat step 1 until 6 for 13 trial of those coins, and then calculate the probability from the result by using the formula. So guys, this is the result. So the sample space for one toss is 1/2, and the sample space for 13 toss is 2 power of 13, that equal to 1073741 outcome. So this is the raw data. So this is the frequency summary for this experiment. So counting for head is about 18 and the tail is 12, so total is 13. So if you can see on the table, for the outcome is head and tail, and number of time is 18 and 12, same like the frequency. So this is the experimental probability of the experiment. As you can see, the experimental probability of getting heads is 18/13, so the value is 0.60, while the experimental probability of getting tails is 12/13, so the value is 0.40. Theoretical probability. So the theoretical probability of getting heads is 1/2, or equal to 0.50, while the theoretical probability of getting tails is also 1/2, so the value of both of it is the same. by looking at the comparisons, we can answer this question. Are the results the same? So the answer is that no. The experimental results are not the same as the theoretical result. So experimental probability for hate is 0.60 is higher than the theoretical probability, which is just 0.50. And experimental probability for tail is 0.40 is lower than the theoretical value, which is 0.50. To answer this question, we just need to use the substitution method, which is we substitute the value of the function first, which is 3 over 15 in bracket x power of 2 minus 4x plus 5. And then we bring the 3 over 15 in front of the integrations and change the limitation 0 and 5. And then we integrate in the bracket and solve in the bracket, substitute the value of x equal to 5 and equal to 0, minus them, and then we will get 25 over 8, which is the value is 3.125. For part B, we are asked to find the cumulative distribution function or CDF of the random variable x. The CDF is defined as fx equal to p in bracket x less than or equal to x equal to the integration of limitation x negative infinity multiplied by ft dt. Since the PDF is only defined between 0 and 5, we evaluate the CDF in 3 intervals. The first interval is x less or equal to 0. So for this interval, there is no probability below 0, so fx equal to 0. For the second interval, which is x between 0 and 5, we integrate the PDF from 0 to x. After integrating and supplying, we get fx equal to 3 equal to x power of 3 over 15 minus 3x over power of 2 over 25 plus 3x over 10. So for the third interval, which is x more than or equal to 5, all probability has accumulated, so fx equal to 1. And the final answer should be like this. So that is the cumulative distribution function for the given random variable. For C, we ask to use fx and find the p in bracket x more than 2.5. So to answer this question, we just need to use the formula that we already learned, and then we substitute the value of the limitation, which is 5 and 2.5, and then we substitute the functions, which is 3 over 15 in bracket x power of 2 minus 4x plus 5 dx. And then we bring the 3 over 15 to front of the integration, and we integrate the functions, and then we just substitute the value of x and solve in the bracket, and we get 11 over 16. For D, we asked to use fx and find the p in bracket x between 1 to 2.5. Same like before, we just use the formula that we already learned and substitute the value of functions and the limitation also, which is 2.5 and 1, and then we bring the 3 over 15 in front of the integration and integrate the functions and substitute the value of x equal to 2.5 and 1, which is the limitation, and minus that, and we got the 9 over 18. In conclusion, this experiment shows how experimental probability can differ from theoretical probability when the number of trials is small. Although a fair coin should produce head and tail with equal probability, which is 0.50 each, the result from 13 tosses produce 0.60 for head and 0.40 for tail. This difference occurs due to random variations, and then human factor, and the limited sample size. As explained by the law of large number, experimental results will only become closer to the theoretical values when the number of trials is much larger. Overall, the experiment deepened my understanding of probability concept and demonstrate how real-world outcomes can differ from idealized expectations.